Well, hi and welcome to my shop. Thanks for joining me here. It's May 11th today, and I'm going to play around with this radio a little bit. I have a couple of things I'd like to investigate, and I think this is a good radio to do it with. So the first one is a question I've had in my mind for a long time, and that is how much noise right at 455 kilohertz, that's the IF frequency for this radio. How much noise is there that's getting right from the antenna right out the speaker when we listen to a radio like this? How much of it is coming right from that frequency? So I want to explore this a little bit with the radio. The first thing I think I want to do is look at the spectrum in that area using my SDR radio. We'll just take a look and see what kind of noise signals there are around 455 kilohertz. Okay, so I'm using a inexpensive SDR, an RTL type SDR, and it has problems. They aren't very good receivers for a lot of reasons. This is it here, this box here. I'm just trying to get these wires out of the way. So using this, I have to consider what I'm seeing. Is it really because of the SDR itself? When we look at the screen for it, is it really because of the SDR itself, or is it something being picked up on the antenna? This is the antenna. This clip lead. That's all I'm using. Just going to leave it laying here, just like you see it, just laying in my shop like that. And now we're going to take a look at the SDR and see what it's picking up. Okay, here's the spectrum. This is 0 hertz here, and the top of it is just past the top of the AM broadcast band, which is shown in blue here. The long wave band is shown in blue down here. In between is the frequency 455 kilohertz. It's right around, well, actually it's where the red line is. The red line is marking 455 kilohertz. So I think what I want to do, I want to zoom in on this area, but before I do that, I think we can ignore the response of the SDR down here. When we look up this way, we see the kind of signals that are just here in my house, in my shop, in that little green loop I showed you. Look at all this stuff up here. These are all quite strong. See, they're all bopping up and down. They probably have, I don't even want to say. I don't want to say anything, but I don't know what these are. Then I have this one, which has been hanging around. Let's listen to this one. I can turn the sound on with my SDR here. We'll just listen to it a little bit. Well, it just seems like it's just a carrier, an unmodulated carrier sitting there. Who knows where that's from? The area we're really interested in, though, is just down here. So I'm going to put the red line down. Just bear in mind how tall these are compared to these little guys here. Just go down. Expand. Expand. So where are we here? 455 is still quite tight in here. Let's go a little bigger. Okay, 455. Put the red line on it, just so we know where it is. So there's nothing in particular but what would look like regular noise here. A little surprised. That's what it sounds like. There is this signal up here, but this is 475. That's 455, that's 20 away. That's a fair ways away. What's that sound like? Nothing. Sounds like nothing. That's just another frequency in here. Okay, we'll take this back. Stick the red line on 455. the bandwidth of the IF, is going to be similar to the bandwidth shown on the radio here, this gray zone right here. Now I'm going to move that coil around. Just going to wave it around in my shop and just see if there isn't stuff happening. So something came and went there. About 490. Not making really much difference at all. Yeah, there's something close to 490. Well, that's kind of interesting. Kind of hunt something down here. Okay, I'm going to change my display so you can see what I'm doing. Okay, now in the meantime I've switched on some more lights in here. It doesn't seem to have added any noise. Get rid of that. Okay, where's my antenna? Here it is. Now I seem to be picking up that 490 thing as I got over here somewhere, but well, there's nothing over here. What was that? It's just nothing on my bench. There's nothing switched on. I'm keeping my eye on the 455 also. There's really nothing much happening. I'm a little surprised. I thought there was some noise of some sort. Let's do this. We're going to hook up the SDR to... Oh, well, that's a little interesting. What happens there? Nothing. Let me turn the sound off. I just realized I left it on. So we're going to hook up to the outdoor antenna. So the SDR is going to be right on the outdoor antenna here. Let's concentrate on the SDR again. Okay, so this gray area here around the red line is basically the bandwidth of I would say most radio IFs anyway. I mean, it's not a square box like that. But now I see there is something right inside here. There's a signal right there. Let's have a listen. Is that this? I'll move over here. Still hear it. Let's just come down through this. Well, there is something. It is making some kind of a buzzy noise, something bumping up and down here. That's very close to 455. Let me narrow down the bandwidth here. And we'll put it right on it. What is it? So it's not a pure signal. Okay, we're going to stop for a moment and I'm going to change antennas. So actually what I just did now was turn on the antenna. The antenna was not turned on, so it didn't make too much difference. Same signal here we're listening to right now. Okay, now I'm going to go and switch antennas and we'll see what happens. So I just switched to a different outdoor antenna. Sounds the same to me. I'm out of the room when I throw the switch, so. But we still have one signal at 456. on my antennas. Okay. So I think what this is sort of indicating is that when I engage my outdoor antenna, I'm bringing in a noise signal very close, well, 456, at 456. Assuming it's the same every day. Maybe it is, maybe it isn't, but today it's there. It's been there the whole time we've been looking at it. 456 signal. Okay, so now we're going to try and see if this radio is sensitive to this signal which I got on my antenna. So what I want to do is make this into a single frequency receiver, stop the conversion of the antenna signals into 455 kilohertz. And the easy way to do that, it sure is easy, just grab a clip lead. We're going to short out the oscillator. I'll do this with the radio operating though. So the oscillator capacitor is this one, and the front end capacitor is this one. And this is the part of the insulated structure that's holding the stator plates. And it's a perfect terminal for me to clip on, just like so, and then it'll just ground it, like that. And that'll kill the oscillator. So there'll be no conversion going on. So the only thing that'll come out of the speaker is stuff that's on the antenna at the IF frequency. We'll find out what this really sounds like. Shouldn't matter where it's tuned or anything. Oh, so exciting. I've wondered about this for the longest time. It's one of those things you think of, while you're driving in the car and you can't do anything about it. So I've got my chance today to do something about this. So we're going to start the radio up. There we go. Shouldn't matter what band we're on. Oh. No, shouldn't. I'm not sure. Well, we're experimenting, so we'll find out. And what band are we on? Okay, so we're on the broadcast band now. So when you hear noise like that, you just kind of assume that's the noise that's coming in from the antenna at the tuned frequency. That's usually what you think. So you can hear all the different things being converted to 455, and they're coming out the speaker as I change the conversion setting, better known as tune the radio. Okay, I'm going to kill the oscillator and we'll see what we hear. And I have zero experience. Now this is a little bit of an antenna here, isn't it? But I don't think it's going to be of any significance. So first thing we hear is a hum out of the radio. That's not very pleasant. Now that could easily be there the whole time, we just can never hear it because the program material is much louder, because I'm turning this up a fair bit here. Okay, the other thing is there's nothing on the antenna at all. Well, okay. Problem with this experiment is this noise. Oh, it's my hand. I'm the noise. Oh! What happened? I just tapped this a little bit. Poor ground there. I wouldn't have imagined it. Okay, I'm going to take a moment. Uh-oh. No, I'm not. I was going to put the knob on, but I don't know what I did with this set. Okay, enough of that. Enough of that. We'll put on this antenna. Quite a bit. There we are. Okay, so the question would be now, this noise I'm hearing, is this noise coming from the tuned frequency, or is it coming from the IF straight through? How can it be the tuned frequency? Nothing is being converted. So the radio is only picking up 455, which means tuning this should have zero effect on the radio. And is it true? Okay, well, it's having some effect, but not the normal. Okay, we'll leave it at the quiet end for now. I'll take my outdoor antenna. Well, that was interesting in itself. Now I just disconnected the antenna from what? From the SDR, and it stopped making sound out of this radio. So there's enough stuff just flying around from this. Where's my, is that really the case? Could that really be? This being my outdoor antenna. Okay, I'm going to put a little lead on it here. Give it a chance. Nothing. Well, why on the SDR did it make so much noise? SDR is just an antenna input. Okay, so I'm going to attach the SDR ground wire. There's no other grounds on this radio to this spot. The radio gets quieter. Just the antenna input lead to my SDR. Hey, stop doing it. This gets stranger all the time. So many things to explain. It's coming back. What exactly is going on? Let me just back this up to see a little better what I'm up to. Maybe I'll get the, I'll leave the SDR there. Okay. What happened? So there's essentially no antenna on this radio. It's doing something. Another thing I've wondered is can signals enter the radio in places other than the antenna? Obviously a strong enough signal, yes, but I mean just the kind of stuff we have in our houses, the kind of noise signals we have. What is going on the SDR? I've not been paying attention to it. Oh, it's because I'm connecting and reconnecting an antenna. So there's a whopper of a signal around 480. What is that? Yeah, anyway, this is experimenting. Okay, you can still see it at 480. It's the same one I was looking at earlier, I think. Where'd our signal at 455 go? It was just here a moment ago. I got it in me. So I think it's just a matter of how decent an antenna you have for the SDR, whether it'll see that 4. Okay, I can be the source. All it means is I just have to touch the antenna terminal on the back of this radio. And we're doing the next experiment here. Okay, let me make sure there's no sound from the SDR. No, everything we're hearing is coming from the radio at a pretty high volume. Pretty high volume. Okay, so I'm going to touch the antenna, but first I'm going to turn this down. Seems like the closer I stand to the radio, the more kind of a feedbacky sound or chirpy sound comes out of it when I'm doing this. I have no idea what I'm doing. Let's just keep doing it though. No more chirpy sound since I turned it down a bit. Okay, antenna test. Touching the antenna. Wow. So this is a radio that theoretically is tuned to nothing and should be hearing nothing. Theoretically, that's not the right word. Assumably, you could say. But there's all that crap there. Holy smokes. Okay, well, what then if an antenna is hooked up? It surely, to goodness, is just going to get louder. Yeah, there you are. Being called away briefly and deal with something else. Well, wow, okay, so a light bulb has come on in my head. I always thought when you have an IF trap, which is a simple circuit to try to snuff out the IF frequency at some point in the radio, usually the trap is right on the antenna, very close to the antenna. I always thought the main objective was to make sure the IF frequency, the local oscillator, doesn't make any sense what I was thinking. I just realized now. I used to think it was to keep the local oscillator from going out of the radio. That doesn't make any sense. The local oscillator is not at 455. Well, I had some dumb thinking. So I guess carrying on in that dumb direction, these radios do produce a strong signal at 455 towards the end of the IF. They're trying to contain it, I'm sure, or there's some effort to contain it in the radio, but it is a radio frequency and it's traveling on wires, so some of it is going to be emitted to some degree. I misunderstood what the IF trap is. Yes. So now I'm thinking the IF trap is really all about preventing exactly what we're getting here, which is a bunch of noise at the IF frequency coming in on the antenna and going straight to the capacitor. And you know what? If this radio had another front end tube, if it had an RF tube and an RF circuit, this problem might be much less. Because the 455 noise signal would have to get past the front end tuning. There's more of it with the extra RF tube. So how much noise is this compared to the noise that the oscillator converts in, if I can put it that way? The radio's tuned to a certain frequency. For fun's sake, let's put it right around 1 million, because that's fun. Having fun? Gotta spot 1 million first. So there's 1 million. You know how you could recognize this problem is it sounds the same no matter where you tune. It's always there, always present noise. Okay, that's interesting. Let's turn on the local oscillator again. Volume's down. So now, what happened to the noise we were listening to? So a couple things may have happened here. There may be a very strong signal coming in from the antenna now. Much stronger than the 455, let's say. That's going through the radio as it should, even if it's just noise. It's still being converted and going through the radio. And the extra signal is causing the AVC to quiet down the radio. So first we have the noise we're listening to on the IF, I'm curious about. Then we bring in another noise at a much higher level, and the radio turns everything down. So this sounds a lot quieter, maybe too quiet to hear. It's still there. It's just we're being fooled by the AVC voltage. So if it's brought down to the point where it's too quiet to hear, who would care about it? Shouldn't care about it. Maybe that's one of the goals of these radios, or one of the factors is the noise coming in at the IF frequency is so low as to be ignored. Okay, so let's listen to the noise again. You know, I could use equipment. I could put signals on. And we could actually measure this kind of stuff. That's quite possible. I could put on a modulated 455 noise signal on the antenna, read the signal strength at the speaker, remove it, or leave it, put a regular signal into the radio, or tune in a station if I could find one, see the signal level, see the difference. There's probably a term for this, IF noise. There's probably a term for this, and I'm just not aware of it for this whole problem. Okay, so local oscillator's off. The only thing we should be hearing, is this really true? I think so. The only thing we should be hearing are frequencies at 455 kilohertz or thereabouts, and that's what we're listening to. You hear the kind of sound it is? Now, I didn't tune the radio. When I had the oscillator running, I could tune to a quiet spot and see if this is what you hear. Let's try that. Can we tune to a spot so quiet? It sounds totally quiet. But see, that's not necessarily a quiet spot. So with these radios, with tuning to a quiet spot, you could be tuning to an unmodulated interference signal. There's so many of them in our houses. And it's coming through the radio. And nothing comes out the speaker because it's not modulated, but it causes the AAVC to cut the volume way back. In fact, I think these radios seldom run at their full sensitivity because they're constantly encountering some level of noise signal all the way across the band. So I believe. That sounds a little like it. So bearing in mind that this is going through a mixer tube, and so these signals that are coming in are stuff is happening in that mixer tube. Could be this sound we're hearing is a bit of a, I don't want to use the word mixture, but I will. Mixture of these two noise signals, one coming in at 450 right from the antenna, and the other one being converted in through the use of the local oscillator. It's just specific to this spot though. Did not have the ground connected during all that. Let me hook up the antenna ground. Why does the radio go so quiet when I hook up the antenna ground? I believe it's because I'm using low impedance antennas, and I'm hooking, as long as there's an awfully long coax lead on this antenna I'm using. But it's a low impedance antenna. I don't know. Just turn it up and get it all back. It's a good thing the volume control was invented on these radios, because man, it saves a lot. So I just noticed one of my known noise sources in the shop was operating. I just turned it down. That noise is gone. Did that just remove the noise we've been chasing all this time? Oh, I should turn down the volume. Okay, so what it is it's supplying over voltage to some LED lamps. That's literally what's going on here. Nope. That often puts radio interference noise out. What happened? Oh, I've got the ground on. So I've got the ground on the antenna. Maybe just turn this up. We'll eventually hear all that stuff again. So I'm going to guess with the two antenna wires connected, the actual voltage level at the end of the antenna is one thing. When you take the ground off and just have the other antenna connected, it's a much higher voltage. I don't know. I'm just trying to come up with explanations for all these weird things I'm coming across. Okay, ground off and noise back. So putting the oscillator back into action here. Putting the ground on and off. Wow, okay. It's a huge difference. Just on the volume though. Well, wait a minute. Wait a minute. I think I'm going to move on now to the next experiment. I've gathered enough observations here. I can't sort it out, but some interesting stuff here to pay attention to. The next little experiment I want to do is I want to try to see all the products that come out of the detector and head to the first IF transformer. What all is coming out of that mixer tube? That's what I want to try to see. Okay, so here's what I've got going. I've got a scope lead connected to the plate of the mixer tube, and the scope lead is just grounded to the B- on the chassis here. Scope lead is set to the times 10 setting. Scope lead then comes through a capacitor here. There's a small capacitor in this box, and then this is a attenuator, a 10-to-1 attenuator. So I believe I've got at least 100-to-1 attenuation in this. And from here, it's going right into my SDR radio. So there's a bit of a risk here to the SDR radio, of course. It can only take so much on the antenna. So I think I'm okay though. That's famous last words. I think I'm okay. You can see the SDR. It's running. Let's just see how sensitive this really is. If I take this off, well, you can see one signal dropped a bit. Not very sensitive. Back on the plate. Now this might disturb the rest of the operation of the radio because it's kind of affecting the first IF transformer. I don't really care. So what comes out of the speaker may not matter. It's really what we see on the SDR. The objective of this is to see, well, what kind of signals are coming out. And what kind of signals are going in, Jim? I just have the antenna hooked up. Well, we start with that. We'll just start with an antenna and see what it looks like. Okay. You should think about what you expect before you do something like this. So what I expect is going to happen is signals on the plate of the mixer tube are looking at a tank circuit that's tuned to 455 kilohertz. If there's a 455 kilohertz signal looking at that tank circuit, it looks like an open circuit or a very, very high impedance. So voltage will build up. That's exactly how they want the radio to operate. Now what if it's not 455? What if it's 600 coming in? 600 coming out. I said that wrong. So if there's a 600 kilohertz signal coming out of the mixer tube, what it's looking at is a low resistance. And so it should be weakened. It should be suppressed. In fact, if it's far enough away from 455, it should be pretty much wiped out, I would think. Far enough away being a decade away? I don't know. Let's try it now. Let's try it and see. What are we going to see? Here we go. You might see the end of my SDR right at this moment here. Well, no, it would take a bit to fry it. Shouldn't fry it. Got a capacitor in here to block the DC from getting over to the radio. It's a small capacitor in there. Let's turn the volume up. This takes a long time to warm up this radio. Something happening. Waterfall display can be helpful here. Was that me touching this? I think it was. Yeah. There it comes. The radio. I hear the hum. Nothing very exciting yet. Okay, let's listen here. Now there's no, yes there is an antenna connected. Well, it's quite possible that this connection is just killing everything. It's just killing it dead. Let's tune the radio and we'll see what happens here. Okay, that's pretty interesting. Turn it down a little bit. The radio seems to be working fine. What is this? So this is up at 488, this signal. And the 455 is still sitting where the red line is. And this is just like nothing. Have I done something wrong? Antenna connected? You'd think there'd be some signal. Especially at 455. If we hear stuff come out of the speaker, it's got to be at 455. It's got to show up on the SDR. It must have padded this down to the point where there's nothing left. Hard to believe. Let's keep tuning around here. Pretty quiet. What happened? They overrode. That's what happened. What do we get here? I'm tuning very slowly. So you can see a little peak going through the IF, right around the red line there, passing through the IF, and we can hear it. It's just noise. There's another one. What's this one? No, another one coming. So the SDR at times cannot process the signals and display them. If the signals are changing frequency, it can't display them. So as I tune the radio, you'll see these signals disappear off the SDR and then reappear when I stop tuning it. I have to go very, very slow to actually watch the signals move. Give the SDR a chance to process it. So here comes another one. Okay, now things are getting interesting. If you look at the waterfall display, well, maybe hard to see. I can see it here on my own computer. Or if you look to the left of the red line, you'll see something moving from left to right. You've got signals moving from right to left and others moving from left to right. So I want to boost the signal going to my SDR. Make this just a little more. Look at all that stuff. Now remember, we're kind of listening to this area here. Whatever's in this area is what we're hearing. Plus, because the oscillator's operating, whatever is at the tuned frequency, whatever noise is there, is also being brought in. So the ones that are being brought in by changing the local oscillator are going to be moving, like they have been. But anything that's just coming straight in would be sitting there. So you don't see anything. It's just sitting there all the time. Let's look at much more of the so now we're seeing much more of the spectrum. The red line's still at 455, and local oscillator may be appearing there. Let me tune the radio and just watch and see. Way over on the right side of the screen is the local oscillator. A huge signal over there. You can see there's something going on right around 1.1 megahertz. This signal here, who knows what it is? I don't know. See all the stuff happening right around here, right around the IF. What's that all mean? Now, I guess something to realize here is we're looking at the output of the mixer tube before it goes through the IF tuned circuits. So on the far side of the IF tuned circuits, or on the output side of it, you're only seeing through a little portal, 455. And if we were looking there with the SDR, we would just see action at 455. But because we're looking at the start of the IF, we're seeing everything that's coming out of the mixer tube spread right across the whole bandwidth, and maybe beyond what's on the screen. Let's look again. Here. There's a reason why I said that. So if you look down in the waterfall display down here around 455, and I'm going to tune the radio back and forth, I think you'll see that there are signals which fade in, and then they're strong, and then fade out. Now, because time is going by and this is scrolling, those will draw angular lines on the screen. And I'll tune one way, one direction, this direction. Okay, here we go. So just watching right around there, and everything I said is baloney. Yes, total baloney. Unless we just can't see it. Let me zoom up here again. So more to see at the top end here. Okay, so there's those angular lines I was talking about. We just didn't have enough signal to make it strong. Those angular lines, as they tune back and forth, are contained in the passband of the IF. So now you say, well, where is the IF actually tuned? So you look at those lines and look for the bright spot in them. Where are they brightest? There's quite a strong signal there. I'm at the end of the road, I guess, yeah. I'm at the bottom. Oh! What just happened there? Okay, I guess maybe a wire came loose briefly. So looking at this and trying to assess, it's a really kind of a stupid way of doing it, but where is the signal strongest? I'm looking at the tallest signal in the IF range. Ooh, there's another jump there. And it is tallest. It's definitely going right in this area here. What frequency is that? 405. So this is probably because the apparatus setup I have has detuned the first IF transformer, and its effect is no longer centered on 455. It's now centered on, well, maybe 405. So 405 has become the resonant frequency of the first IF transformer. So anything coming out of the detector, the mixer tube, I hope I'm not mixing too many terms up here, anything coming out of the mixer tube is encountering a resonant circuit not at 455 but at 405. That's probably what's happening. Another interesting thing. Let's see what other interesting things we can come up with. I'm just making observations here. Let me bring the local oscillator in. So I'm driving down the oscillator frequency, and we can see through the, oh, what was that? Boom! What's going on? Is that my antenna doing something outside? I have a loose antenna connection? Oh! Am I doing that? Yeah, it would appear like it. Something a little loose here. Just one sec. Not sure. Okay, this seems to be the stable area. Back to what we were doing. What were we doing? We're just playing around here. So, okay, so if you look down at the red line in the IF, never mind what's going on with these signals jumping up. I have a strong signal sitting in the IF right where the red line is. And now I'm going to move that signal off to the left by, that's got to be a converted in signal, mixed in. So I'm moving it to the left. Now how far can it go? And I can still see it. A long ways. Wow, all the way out to here. So that means inside the radio right now, the local oscillator where it is, there is a signal being converted down to 125 kilohertz and being presented to the IF. But the IF is not interested in that signal. The IF is only interested in 455 and thereabouts. Let's go the other way now. We'll get the same signal back in the middle of the IF. Whatever it is, well, we can listen to it. What is it? Let's listen to it. Okay, I'm going to turn the speaker on here. Okay, in AM mode. And I think the bandwidth is really tiny here. Let me open it up. That's a pretty spooky sound. Whatever it is, who knows. Now I'm going to tune the local oscillator to the right, and we're going to move that signal to the right. How far can we watch it? Oh, come on, what's going on there? Maybe I'm touching the radio? I don't know. What's going on. I'm tracking it. I can still see it. To the right. I can still see it. Way out to here. It's way out around 900 now. So what this tells me is that idea that the IF input resonance is going to result in the elimination or suppression, I guess is the right word, the suppression of all signals outside of 455. It's not very dramatic. You can still see a signal being converted by the local oscillator way far away from 455. So I mean, if you took another radio, tuned it to, let's say, 700, a regular AM radio tuned to 700 kilocycles, and then messed around like I'm doing now, take that other radio, get its antenna sensitive to something going on inside this radio, similar to what I'm doing with the SDR. Could you make that other radio receive what this radio is converting? It's an interesting question, because in my shortwave world, when I'm listening to radios, sometimes I have 2 or 3 radios running simultaneously, all on the same antenna. So if there are signals making it out of those radios and onto that antenna wire, it's going into all the other radios. It makes the scenario I'm looking at here just, multiply it by the number of radios you've got going. Everybody hearing everybody. Now for sure you can hear local oscillators in other radios. If you have multiple radios going, one radio can pick up the local oscillator of the other one. And don't need to even have antennas not necessarily connected together. So what is this getting me? What am I getting out of this? I'm just getting insight into all those sounds that come out of these radios and what is going on. What is really going on. Of course, the reason I'm doing it with this radio is because this one has no front end RF section. The antenna basically goes straight to the, not quite straight, but through a slightly crooked path to the grid of the first tube, the mixer tube. So this one's got it's got a wide open mouth on it, and everything that's on that antenna is ending up more or less on the grid. Now it's suppressed. It's suppressed by antenna tuning. I can't remember what it looked like. I have the schematic right here. I do. So a quick look. So I have all these coils and tuned coils here. But the signal has to get through these coils to get to here. So there's a certain resonance in here. So if you're outside of that resonance, your signal is weakened. You have to go quite a ways though, because it's just one set of tuned coils. I think if you put an RF tube here, you get tuned coils, RF tube, tuned coils, then mixer. And that's really the advantage. 2 sets of tuned coils instead of 1. On some radios, these tuned, in a simple AM only radio, the tuned coil here is the antenna, the loop antenna on the back of the radio. And if you take away, if that antenna is lost, maybe you picked up a radio somewhere, there's no back, and you didn't realize it, but the antenna is gone too. So you're hooking up wires, you're basically hooking up wires straight onto the converter grid. It's just that much more of all this stuff we're looking at would be happening. Okay, maybe I beat this to death at this point. I'm not sure what else it is I want to look at. Yeah, so maybe this is the end of the video for today. There's just a lot of things to think about and be aware of. And as I proceed through other radios, to look for and ponder. And maybe there's some important discoveries or some things I need to have in my head here to do a better job at all this kind of stuff. So, okay, well, thanks a lot for watching to this point, and I think it's another fantastic day outside. It's the first truly hot day. It might get to 28 today, so that's where I'm heading next. Yeah, thanks a lot for watching, and we'll see you tomorrow.